All right, we want to look at rational expressions. The root word of rational is ratio, so we're basically talking about something that can be written as a fraction. And today we're looking at polynomial fractions. So if I want to simplify this rational expression, I need to factor the numerator and denominator and see if they have any common terms that I can eliminate. So for instance, in my numerator, we could take out the greatest common factor of 9x. So if we take out the 9x, we'd be left with 30x plus 1. Now, if you're unsure about how to take out the greatest common factor or factoring in general, we're going to do a ton of factoring in this section, then you can go back and look at the previous video where we talked about factoring. So for this, we can cancel our 9 and 3 because 9 goes into 3 3 times. So we'd have a 3 in the top and a 1 in the bottom, and then we can cancel our x here with our x here. So that's going to leave us with 3 in the numerator times 30x plus 1, and then just 1 in the denominator. So we can leave that in its factored form, or you can distribute that 3 back through to have 90x plus 3. All right, look at the next one. So to begin with, we need to factor our numerator and our denominator. And again, if factoring is a struggle, be sure that you go back and look at our last video. So once I have my numerator and denominator factored, you'll notice that they both have an x plus 4 in common. So I'm going to eliminate the x plus 4 in the top and the bottom, and that would leave me with x plus 4 over x plus 7. Now, can you eliminate that x right there? Well, no, you cannot cancel things that are being added or subtracted. You can only cancel things that are being multiplied. So you'll notice in that first example, we were able to cancel with the 9x because it was being multiplied by the other term. And we were able to cancel the x plus 4 because it was being multiplied by the other term. But here you'll notice that x is being added to 4 and x is being added to 7. All right, look at the next one. So again, for our first step, we're going to factor. So our numerator is a difference of squares, and our denominator is a trinomial that will factor into two binomials. So once we have it factored, then again, we're going to look for anything in common that we can cancel. So we're going to cancel x plus 3 in the numerator and denominator, and that would leave us with x minus 3 over x plus 1. Nothing we can cancel there, so that is our answer in lowest terms. All right, look at the next one. For the next one, there's no way to simplify the numerator, but our denominator is a difference of squares. So if we factor that difference of squares, we'll have x plus 6, x minus 6. And then we can eliminate anything that is in common. So you can see we could cancel the x minus 6 in the numerator and the denominator. So in my numerator, what I have left is 1. And then in my denominator, I have x plus 6 times 1, or x plus 6. So my answer would be 1 over x plus 6. So now that we know how to simplify a rational expression, we want to look at how can we add, subtract, multiply, and divide them. All right, let's start with multiplying and dividing. So for our first problem, for number 5, we'll start the exact same way with we want to go through and we want to factor everything. So our numerator is a trinomial that'll factor into two binomials. And then we can take out the greatest common factor out of that denominator of the first fraction. And so if we take out a 3, we're left with x plus 6. There's nothing in that second fraction that will factor, so now that we've got everything factored, we can start eliminating. And whereas before we were canceling up and down, when you're multiplying, you can also cancel diagonally in both directions. So you can cancel vertically and diagonally, you just can't cancel horizontally, all right? So you'll notice that diagonally, our x plus 6 will cancel with our x plus 6, and our x plus 5 will cancel with our x plus 5. So what we would have left would be 1 times x minus 1 times 1, so x minus 1 in the numerator, and then in the denominator 3 times 1 would just give us 3. All right, what do you have to do differently when you are dividing fractions? Well, when you're dividing fractions, you have to stay, change, flip. So the first fraction is going to remain the same. Then we're going to change our division to multiplication, so change. And then we're going to flip this second fraction. So stay, change, flip. And now we're right back to multiplying, exactly like we were doing in problem number 5. So I'm going to begin by factoring everything. So this trinomial factors into 2 binomials. X squared minus 1 is a difference of squares. This trinomial factors into 2 binomials, and x squared minus 4 is the difference of squares. So then remember that you can cancel vertically and diagonally. So I could cancel this x plus 1 with this x plus 1, and I could cancel this x plus 2 with this x plus 2. So what I would have left in the numerator would be 2x minus 3 times 1 times x plus 1. So 2x minus 3 times x plus 1. And then in the denominator, 1 times x minus 1 times x minus 2. So that would just be x minus 1 and x minus 2. And that would be my final answer. Now, when I am adding and subtracting, it makes it a little more challenging because you can only add or subtract if you have a common denominator. So whereas back here with number 5, we were able to multiply even though our denominators were not the same. When we're adding and subtracting, those have to be identical. All right, so I want to find the least common denominator for x plus 5 and x minus 3. For the least common denominator, I have to keep the highest power of everything. So I had an x plus 5 to the first and an x minus 3 to the first. So I'm going to keep each of those. So I need to rewrite this fraction with this denominator, and I need to rewrite this fraction with this denominator. All right? So to get from the original denominator, x plus 5, to the common denominator, x plus 5 times x minus 3, you can see we multiplied by x minus 3. So if we multiply the bottom by x minus 3, we have to multiply the top by x minus 3 as well. You can see if I went back and canceled this out right here, I'd go right back to that same fraction I had. So you can see we haven't changed anything. Similarly, if you look at x minus 3, to get from x minus 3 to our new denominator, you can see we had to multiply by x plus 5. So what we do to the bottom, we also have to do to the top. And again, if we eliminated that x plus 5, we'd go right back to the same denominator, the same fraction we had a second ago. Okay, so what was the purpose of getting a common denominator? It's so we can combine our two fractions. So let's do that. Let's combine our two fractions over that common denominator. So we've got 2 times x minus 3 minus x plus 5. 2 times x minus 3 minus x plus 5. Let's simplify our numerator a little bit. So we're going to distribute that 2. So 2 times x is 2x, and 2 times negative 3 is negative 6. And then here, remember there's an understood 1 right here, so negative 1 times x is negative x, and negative 1 times 5 is negative 5. You'll also notice that when you have a negative in front of parentheses, it changes every sign that comes after it. So you can see the x becomes negative and the 5 becomes negative. All right, so now let's combine like terms. What's a like term with 2x? Well, negative x. So we could combine 2x and negative 1x to be a positive 1x. And then, of course, our constants are like terms. So we can combine negative 6 and negative 5 to get the negative 11. And you can leave it in this factored form. I like to leave it that way just so I can see that there's no common factor that will cancel. But you also could FOIL it back together again if you wanted to. All right, look at another one of those. So again, I need a common denominator. So I'm going to start off by factoring and find my least common denominator. Now, some people, for their least common denominator, they just keep all their denominators. So they would keep this guy, which is x plus 2 times x plus 2, and they would keep this guy, which is x plus 2x minus 2. In that case, my least common denominator would be x plus 2 times x plus 2 times x plus 2 times x minus 2. That is a common denominator, but it is not the least common denominator. It'll work, but I'll have to do a lot of extra work that I don't want to do. So when I'm trying to find the least common denominator, I have to keep the highest exponent. I have to keep the highest term of everything. So you'll notice over here I had x plus 2 to the second, and here I had x plus 2 to the first. So I'm going to keep x plus 2 to the second. And then I had x minus 2 to the first. I didn't have any more x minus 2's over here, so I'm just going to keep x minus 2 to the first. So there's no need for me to keep the two x plus 2's over here and the x plus 2 over here, because again, we keep the highest power. I had x plus 2 to the second. Here I had x plus 2 to the first, so I keep x plus 2 to the second, and it covers both of them. Okay, so now that I have my least common denominator, how did I get from here to that least common denominator? Well, I had to multiply by x minus 2. So what I do to the denominator, I also have to do to the numerator, right? Similarly, how did I get from this denominator to the common denominator? Well, I had to multiply by x plus 2. So whatever I do to the bottom, I got to do to the top. So you can see we're multiplying top and bottom by that x plus 2. So again, the reason that we get a common denominator is so we can combine our numerators. So let's do that. Let's combine our numerators over that common denominator. So we had 6x minus 2 minus 2 times x plus 2. So you can see that same thing down here. So now let's clean up that numerator. I'm going to need to use the distributive property. So I'm going to say 6 times x is 6x. 6 times negative 2 is negative 12. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. All right, so now let's combine our like terms in our numerator. So in our numerator, 6x and negative 2x are like terms, so that would be 4x. And then negative 12 and negative 4 are like terms, that would be negative 16. I always want to look at my final answer and make sure that there's nothing else that will factor and cancel. So I'm going to take out a greatest common factor of 4 out of my numerator just to make sure that there are no common factors that would cancel, and there aren't. So that is my final answer.